Moving forward from today's class, we learn how to merge tables, how to merge data frames in R, how to merge the data frames in R. So for this, we'll import two files. Let me set my working directory and let me import two files from where I'll get the data. So this is my working directory. Okay. Once I set my working directory, replace all with a double backslash and press Control Enter. This will set a working directory for me. Then I will import two tables. So let me show you data one. It's a CSV file which I'm importing. So according to yesterday, for a CSV file, we need to write read.csv and the name of my file is r1.csv. Okay. If you see, I have two files, R1 and R2. Let me show you all what R1 has. So R1 has this data, name, location, and ID. And R2 has this data, ID, age, and gender. So ID is the common column between the two tables. Okay. And we'll see how these two are merged. For now, you can see that in the first table, there are 8 names. Okay, there are 8 names if you all see A to H. Okay, and in the second table also there are 8 names, 8 people. Okay, now we'll see what result we get in R. So read R1.csv and data2 is equals to read.csv R2.csv. R2.csv. Okay, so we have got our two tables. Now, how do we merge the two tables? Using the merge function, we merge the two tables. Okay, so we write merge of data 1. R is case sensitive, so please write whatever you have defined above. Merge data 1 comma data 2, and by which column you need to merge it? You need to merge it by the common column, which is the ID column in these two data sets. Okay, if you run data 1 and I show you run data 1, it says me name, location, ID. Run data 2, it will come the same as it was in Excel. Okay, ID, gender, and so the ID column in both. So I'll write by is equals to ID. Should merge the two tables by ID. So see, ID is the common one. Then I get the name, then I get location, I get age, and I get the gender. But I have got only 7 rows of data. Why didn't I get the last row, the one with 23 age, or the one with male, or the one with ID HNE2, or the one with ID HNE1? Because these two were not common in both the tables. Merge will merge only those data which is common in both the tables. Okay, I'll share, but I would want you all to see on screen first to understand. Next, if I want to see all the rows of the first table without omitting any other row, without omitting any row which is not present in the merge or which is not present in the other table, how do I write is, I will write merge of data 1, comma data 2, comma all dot x, the x means the first table, all dot x is equals to true. All dot x is equals to true and y is equals to id, obviously. So merge of data 1 comma data 2, all dot x equals to true means I want all the rows of the first table, whether or not there's a common id present in the other table for the same row or not. So when I do this, I get all the rows of the first table, and for age and gender, since it was not present, it was giving me an NA. Similarly, I can do a merge of data 1 comma data 2 comma all dot it is common for any table which we use. It's just that X means the first table you're specifying in your syntax. Y will mean the second table you're specifying in your syntax. Okay, if I write all dot y is equals to true, it means data 2 it will use. Okay, so this is denoted as X, this is denoted as Y. If you use any other table in the first place, it will be denoted as X, and the second one will be denoted as Y. I didn't understand, what do you mean by TXS? Okay. All dot y is equals to true. No, you cannot define first is y and second is x, because the syntax says merge x comma y. So only way is data 2 comma data 1, then data 2 becomes x and data 1 becomes y. I cannot write all dot y is equals to true and expect that it will pick up the first table. Or I'll write all dot x equals to true and expect it will become the second table. Okay, it depends on our syntax, because our syntax says merge of x comma y. First is x and then is y. Y is equals to id. So when you run this, you get, see, you don't get the all rows of table 1, but you get all rows of table 2. Okay. And similarly, if I write merge of data 1 comma data 2 comma all is equals to true, comma all is equals to true, then you get all rows of the first table and all rows of the second table. Okay. Now for for one thing which you all can change, or when you all can define in the syntax, is I did not write x equals to or y equals to. If you write x equals to data 2 and y is equals to data 1, then you can change your x and y. But again, it represents only the format of the data which you have changed and nothing else. Okay, all dot x is equals to true. So this will now, x now becomes data 2. But again, x is the first one. You're just changing positions. Data 2 becomes the first one and data 1 becomes the second one. Okay, you're just changing positions of writing. But whatever you write, you have to write it. The first is always x and the next is y. Okay. Is the merge clear? No, you cannot merge more than 2 tables. You have to merge, you have to merge 2 tables, and the third and the final table can be merged with the third table again. You cannot use more than 2 tables. At least, see, understand the syntax. Please follow the syntax. The way why I am using R Studio is because you get to get these things where you can read what can happen. So if you see merge 2 data frames, by a common column or a row. Okay, so please read these syntaxes and what they are saying. Moving on. Yes, then you write by is equals to whichever row name is there. Okay, whatever row name is there, you write the row name. Generally, we never merge by rows. We only merge by columns. How can you merge table by rows? Understand, if you merge two tables, you need to have a common column. By row is something you don't do generally. No, we do not merge table by rows. Exactly my point. We never merge table by rows, but it's just written in R. Okay. Next, please. Next, how to return the headers of the how to return the headers of the table for any data frame. If you just want to return the headers or you just want to see the names of the table, how will you do that? Now, currently, it's a very easy scenario where you see that, okay, you have the entire you have the entire, your table is very small. So that is why you do not you find it very easy to see the names of the header. But when it's a very long table, when you work in the industry, you have 20 columns, 30 columns, 70 columns, 80 columns. It's not possible for you to see the headers all together at one point of time. So how do you return the headers of the table? Only the headers without the data is using the names function. Okay, names, and if you provide the data table name, suppose here I am using data 1, then it returns me the name, location, and ID. It returns me the headers or the headings of the table. Is that clear? Then if I want to rename a column, I want to rename a column. Okay, suppose I do not like a column name, or if I see some mistake in the column name and I want to rename the column. How do I do? I write the table name, which is, first I write obviously names of the table name, suppose data 1. Okay. And then I will write the column number for which I did not like the name. Okay. So suppose I did not like the name of the third one. Okay. I have to change it to small. I have to change it with to small d. I want to do it with small d. So names of the table name of the third position, and it has to be ID, the one with a small d. Okay. Now, if you run names of data 1 again, see, it will give me the one with changed name. So this is how you rename a column. Okay. This is how you rename a column. Next, finding duplicates in a table. Finding duplicate rows. How to find duplicate rows in a table? So again, I'll import one table. I'll import this table. Okay. So again, the directory is same. We'll just store it as data3, read.csv, table duplicate.csv. Okay, and data3 will get imported. Okay, this is a data name, age, gender, which has some duplicate rows. I have created this data manually. Okay, so this has some duplicate rows. How do I find the duplicate rows in the table? How do I know that the data has duplicate rows? Again, you write the table name, data3, and then you put the filter sign on the row side. On the row side, you write duplicated of data3. On the row side, you write duplicated of data3 and you give a comma. That means you need all the columns and you just want to get the duplicated rows of data3. You want all the columns and you want to get the duplicated rows of data3. So there are 3 duplicated rows, 5, 11 and 19. Remember, these are duplicate rows. The original row has not come. So if you see the first time D occurs is at row 4, then the same row occurs at row 5, then same row occurs at 11th position, and the same occurs at 19th position. The one with the 4th row will not come because that's the original and all others are duplicates. So 5, 9, 11 and 19 are duplicate rows. Okay. If I want to remove the duplicate rows from my table, if I want to remove duplicate rows, remove the duplicate rows from my table, then how do I write? Firstly, all these data are just displayed. It's not getting stored. Okay, for storing, I told you all yesterday that you need to store it like this. Okay, currently I'm not storing any data. I'm just displaying the data. Okay, now if I want to store the duplicate rows, remove the duplicate rows and then store the new table. So suppose data 4 is the table with removed duplicated rows. How do you remove the duplicated rows? You write the same syntax. You write the same syntax over here. You write the same syntax, but with a not equals to sign. But with a not equals to sign, an exclamation sign. Okay? Or one with an explanation sign. That is not duplicated rows. Okay? It removes the duplicate rows from my table. So if you see data 4 now, see it doesn't have the 11th row, it doesn't have the 5th row, and it doesn't have the 19th row. Okay, so it removed the duplicate rows from my table and it stored the values in data 4. Clear? Is this clear to everyone? Now, next question, adding rows to the data. How do you add rows to a given data? Adding rows to a given data. How to remove the duplicate rows from my table? So that is data 4. I will store the data. I will store my new table in this table. The new table will be the one which will not have the duplicate rows. Currently, data 3 has duplicate rows. In data 4, there will be no duplicate rows. And how do you remove the duplicate rows? You use an exclamation sign with duplicated of data 3. Is that clear, Harshangi? Now, adding rows to a given data. You have a table and you need to add rows. You use the function rbind. You use the function rbind. Okay, so rbind helps you to add rows to a given data set. Okay, so if I write, say I have to add data to data 4. I have to add a row to data 4. So I will write rbind data 4. I will write rbind data 4. And suppose I need to manually enter. So I will write C of say Q, again in quotes please, Q, comma, say 45 and say comma male. Okay. Data 4, comma C, comma Q, comma 45, comma M. It has to be, obviously the number of columns has to be the same. The number of columns has to be the same when you do an rbind. So here I have entered 3 values for 3 columns. So see, this got added Q45M. Again, this is not stored. So you can override data 4. You can override data 4 with this data. Okay, you can override data 4 with this data. So when I store it, now data 4 has Q45M also. And you can see the row number is completely separate, 171. It's just starting from 1 again. Okay, don't go on what serial numbers are assigned here. Just understand that this has been added. Okay, if I have two tables which contain the same data, okay, you can sorry, that was my mistake. You have to write it as numeric. Thank you for correcting me. So see, now again a new thing which you can learn from here is I have already added Q45M in this data 4. If I again add the same data, we'll have duplicate rows. Okay, so what you can do from this is, first you can remove this row. Okay, you can remove this row. How do you remove this row? Data 4 is equals to data 4 minus 171 comma this. Okay, data 4 minus 171 comma row, which will remove this 171th row from here. Okay, now you see it did not get removed. Let me try with the how many rows are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Or you can use like this, minus of length of data. Use this. Instead of counting, use minus of length of data flow. So this will remove the last row from you. That is a syntax of R. I cannot change that. And you cannot get 19 as well. You see, you don't have 11 in between. You don't have many numbers in between. You don't have 5 in between. But that is completely a syntax of R. Data 4 minus length of data 4. It's not working. Or maybe I will see. And of data 4. Yeah, end row works. Length is not working, but end row works. End row will give you the number of rows in the data. End row gives you the number of rows in the data. So if I write data 4 minus end row of data 4, the last row will get removed. Okay, the number of rows in the data is the total, and the last row will then get removed from this data set. Okay, minus of n row. N row gives the number of rows in the data, and minus of n row means the total number. Suppose it was 19 rows, so minus of 19th row. So last row gets removed. Okay. Once I run this, I can again store data 4 with data 4 and rbind of data 4, comma C of Q, comma 45, comma mail. And you can get the new data 4. Yes, if you run the syntax again, then the 18th one will be removed. Exactly. If you run twice, if you run thrice, one row will get removed every time. Okay. So data 4 rbind, and I got the qth row again. Okay. This was removing a row, and this was adding rows. Okay, removing and adding. Now this was adding rows manually. If I have two tables with the same data, that means same data means the headers of the data of both the data sets are same. In both the data sets, I have name, age, and gender. Then I can have an rbind to the data set. Okay, rbind of say data 3 comma data 4. Data 3 and data 4 both have the same headers, name, age, and gender. So I can combine these two data sets. So see, rbind will now just put one data below the other. Name, age, and gender. The columns has to be same, and it just puts the data one below the other. So first data set is still 19, and the second data starts from 110, and it gives R gives the number according to its own choice. So I don't have any rule over the numbers. It just gives the number over its own choice and puts the number below. Okay, so the two data have got merged one below the other on the same basis of same column. Okay, you have added columns to one table. Again, you can store this into a name. You can store this maybe into data file. Okay, you can store this. Until unless you store, these are just getting printed. Like rbind, we also have cbind. Like rbind, we also have cbind. Combines our objects by columns. Combines our objects by columns. Okay. So basically, if I want to cbind, if I want to do a column bind to any data, say I want to add column to my data 1, which was R1. Okay. In R1, I had 8 columns. So say I want to add the columns which I had over there was name, location, ID. Say I want to add a gender column. Okay. Say I want to add a gender column. Then how will I add one column? I know it's data 1, but then how will I add a column? So I will write C of say M, F, M, F, F, M. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. See, how did it come up? Can you be use rbind and cbind together while creating a data frame in a single syntax? No, you cannot use rbind and cbind in a single syntax. No, you have to use different syntaxes. Okay, now you see the data got merged, but the column name is not coming correct, right? And this data is not stored as well. Say I store it into data 6. Okay, and I taught you all how to change the names. I taught you all how to change the name. So names of data 6, fourth column, you wanted to change it to gender. Now see, you run data 6. Sorry, you just have to run data 6, not the entire code. This comes to gender. Okay, the name has changed. Is that clear to everyone? Is this clear to everyone? Cbind. Okay. Now for cbind, I can also use two tables. I can also use two tables, okay, with the same number of rows. You can with the same name correct directly. No. Then I have to try. Just trying this. No, it doesn't come direct. Okay. You have to use and change it. Next, we can also use cbind when we have two data tables of the same number of rows. But cbind does not use any sort of intelligence when combining two tables, like merge. Merge uses sort of intelligence when combining two tables. It will see a common column and then only will put data together. cbind just places the data one beside the other. So if I do cbind of data 1 comma data 2, I do cbind of data 1 comma data 2. The only criteria which cbind works on is that both the tables should have the same number of rows. Both the tables should have the same number of rows. Okay. So data 1 comma data 2, and I run this. See, it just places the two table beside one beside the other. So ID is coming two times, HNE1, HNE2, and so on. So it's not that it is using any sort of intelligence while combining the two tables. It just places one table beside the other. rbind and cbind are generally used to add one or two columns or rows to your data. Is that clear? Next, sorting in R. Sorting. Remember yesterday we did sort for vectors. We did sort of vectors where we wanted to arrange it in ascending order, arrange it in descending order. Similarly, we can also arrange our data frames in ascending order or descending order. Okay, we also can arrange our data frames in ascending or descending order. rbind is appending two tables, right? rbind is able to achieve that. rbind is appending two tables depending on what, depending on the columns need to be same. Okay, the column headers need to be same. So there is a way of achieving. rbind will append two tables. Append means adding. For those who don't know the meaning, append means adding the values to the table. Sorting in R. So for data frames, suppose I take what was the duplicate table name? Data 3. Data 3 was a duplicate table name which I had. Okay. And over here, I want to arrange the ages in ascending order. Okay, I want to arrange the age in ascending order. So data 3, again a filter bracket. You write data 3 comma data 3 dollar, sorry, order. First you write order. Then in square brackets you write data 3 dollar age. Order of data 3 dollar age. Okay, data 3 is a table name. then order of data $3 age, and you want to retrieve all the columns. So on the column side, we will not write anything. On the row side, we'll write order of data $3 age. Okay. So see, if you see, my age has now been arranged in ascending order: 15, 17, 17, 17, 23, 27, 32, and so on. It's all arranged in ascending order. Okay. If you want to arrange it in descending order, you just put a minus sign before age. You just put a minus sign before age. Okay. It's very logical. If you all understand logic, so if 1 to 10 is arranged in ascending order, then 1 is the minimum and 10 is the maximum. Okay. Now, if you multiply, now just think that if you multiply the 1 to 10 with a minus sign, with a minus 1, okay, it becomes minus 1 to minus 10, with minus 1 becoming the maximum and minus 10 becoming the minimum. Okay. So R works on absolute values with a negative sign. So data 3 order of minus of data $3 age. And when you run this, see, it's all sorted in descending order. Okay. It's all sorted in descending order. Clear? Uh, please check your table. Because such error should not come. Try to run it again if you see, or maybe see if you've made a mistake. I cannot see a mistake in the code, but see if still there is something. If your age is a capital A or small a, please check that. Because R is case sensitive. Anybody else? Uh, is your age all numeric or is it characters? Is your age all numeric or is it characters? If it is characters, then it will not work. Please check your structure of the table. Yes, so please convert it to numeric. How you can do that is, how to convert character to numeric is, yes, I'm coming to that. You can write as.numeric of data dollar age or whatever your table name is. As.numeric. So basically, yes, just convert it to as.numeric of data dollar age. And then run it again and see. As.numeric. Still shows character. Please write I understand. Just You can use this G is equals to G, or just use this G dollar age is equals to as dot numeric of G dollar age. Then it will get overwritten. Just use this. Why are you using dollar signs? For which portion are you asking, Kashish, that why are you using dollar signs? Yesterday we had learned that the dollar signs are used to represent the column names so that it gets understood that from which data, which column needs to be picked up. Okay. Again, for sorting, for alphabetical orders, descending will not work. Only ascending works. Okay. For alphabetical sorting, descending alphabetical sorting does not work. Only ascending works. Yeah. So if you write data 3, comma, order of data 3, dollar gender, sorry, the comma, yeah. So see, it gets sorted in ascending order, gender F, 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 M, M. But if I do the opposite, it will give me a invalid of argument to an unary operator because it does not work on characters. The minus sign will not work on characters, and it is viable, right? Because characters cannot be multiplied with a minus one. Only numerics can be multiplied with a minus one. Okay, clear? Order is clear to everyone? Next, please write if statements in R. If statements. If statements in R. Before if statements, we'll do the logic. We'll just list down the logical operators. So logical operators are equals to equals to. That means it's an equal to sign. I'll write with a hash, otherwise it will not work. Okay, equals to equals to. Then there's a greater than sign. Then there is a less than sign. Then there is greater than equals to. There is less than equals to. There's a not equals to. There is a is dot na. That means whether there is a not applicable scenario present, okay, or there is a missing data present. Okay, checks whether there is a missing data. Is dot na checks whether there is a missing data. There's and, there's or is denoted by a pipe, okay, on your keyboard. Pipe is on the key above, key below the backspace. Okay, key pipe is on the key below the backspace. Shift and backslash key will give you pipe. Okay. Then we have percentage in percentage. These are the logical operators we'll operate with in R. Okay. Percentage in percentage works for multiple ors. Is dot na will check the missing value, check missing data. Yeah, null as well. So anything which is NA or null or missing data is dot NA will check. Okay. So whenever you import anything into R and there is null, R by default replaces with an NA, replaces it with an NA. Okay. If you import anything in R or there's something blank in R by default replaces it with an NA. Okay, that is why the function name is dot na. Clear? If statements, so if statements in R, I'll come to that, Athar. Please wait. I'll come to that in the later classes. This will be used. If statement in R, I'll come to that. Let me please complete how to. Let me please complete the portion I'm doing. Then I'll come to all your doubts at the end of the class. So if statements, there are three types of if statements we learn. First is the normal if statement, just the if statement. Okay. So if I declare x is equals to 55, okay, if I declare x is equals to 55, and I tell you, check if x is greater than 0, if x is greater than 0, print positive number, print positive number. And there is no else statement. There is no else statement. So it will just print a positive number. Okay, if x is becoming minus 55, it will not print anything for you. Okay, it will not print anything because it does not meet the condition. Then is an if else statement. If else statement where we give an else condition as well. Okay, so if the condition is not met, then what will it print? So similarly for here, if x is greater than 0, if x is greater than 0, print positive number, else will come outside this curly bracket, else a new curly bracket opens, print negative number. Okay, so if x is greater than 0, print positive number, close curly brackets, else open new curly brackets, print negative number. Now if I run this, it becomes a negative number. Okay, is that clear to everyone? Okay. And the last one, but these will work only for a single number array. Okay. These will not work when we have more than one numbers in an array. Okay. It will work for a single number only. Okay. If you have to work it with more than one numbers, then we'll have to use loops, which will come later. Currently, the third statement which we'll use is the if else statement. Directly if else. Okay, no breakage, is just the if else statement. Okay, and this works, generally we use it for data frames, and like this works exactly like the if functions in Excel. Okay, so first is the logical test, then we have yes, and then we have a no. So that means yes means if the logical test is true, then what you get, what should it print? And if the logical test is false, then what should it print? Okay. So suppose I create another column data $x, okay, which will give me the answer. And if else statement, I write that if the table, data $3 age is greater than 20. If data $3 age is greater than 20 and data $gender and data $gender is equal to female. Data $3 age is greater than 20 and data gender or data $3 gender, sorry, the table name has to be the same. And here also data 3 is equal to female. Then denoted by say 2f, okay, denoted by say 2f, otherwise denoted by other, okay. And if I run this, see what do I get. You just need to run data 3 because that's your original table and your answers are here. So an extra column has been created, X in the data 3, where it checks that whether the age is greater than 20 and it is a female. Both greater than 20 and female together. So here it is greater than 20. Yes, but it is not a female. So this becomes a false condition. So it goes to other and puts it. Here it is greater than 20. Yes. It's a female. Yes. So it puts a 2F. So multiple printings get together for a data frame if you use a if else statement. Clear, everyone? This statement is clear to everyone. I hope this clears your doubts as well for multiple conditions. Now, if you have another condition, if you have multiple conditions, like let's take an example that if again I'll create X, I will overwrite X, okay? So doesn't matter. If else data $3 age is less than 20 and data $3 gender is equal to female, you give me 1F. Otherwise, if else, again, otherwise there's a condition if else. Okay, I can use an if else inside an if else, that if data $3 age is greater than 20, greater than equals to 20, and data $3 gender is equal to female, then you give me 2F, or else you give me other. So this else will work for both. The last else will work for both. And this is the first condition, this is the second condition, and so on. Yeah, I corrected it. Yeah. So now if you run data 3, see, it is giving me 2F, 1F, and other. Okay, it is giving you 2F, 1F, and other. You can see the full code here. That if data $3 age is less than 20 and gender is equal to female, I get 1F. Else, if this is the first true, then else, if data $3 age is greater than equal to 20 and gender is equals to female, give me 2F. Otherwise, for all other scenarios, give me an other. Okay, is this clear to everyone? And percentage in percentage is used for multiple ors. Okay, you will find a question in the assignments where you will find multiple or questions. I would like you all to first try and then we can discuss the multiple or scenario. That's it for today. Anything else which you all want to ask? I am stopping the recording.